Hey, okay, I've got two people. There's always one. So I currently have one, so I'm not quite so panicked. My apologies, I had a little technical problems set up. Somebody tell me that I can indeed be heard, since they're not watching. Okay, make the font bigger in Emacs. Sorry about that, I forgot to do that one. Yes. Okay, the sound is good. Okay. Yeah. So, does somebody have a problem they'd like me to work? If not, I'm going to work this one. And I will wait for that. Okay. Not hearing last minute suggestions for problems. This I don't think will be a long problem. I think I'll just start working it. All right. As I've been doing, I'm just doing these live. So, first off, we have to pick a name, obviously. Plain to square cipher. And this is a good name because it expresses relationship. Plain to encrypted square cipher. So, I'm going to get the text. Let's assume the text comes in as okay. This, by the way, it won't do some in-text coloring until you complete it. So I've kind of gotten in the habit of doing that. Just a little trick thing I do. And then we also want to check for the case that somebody sent us kind of the wrong thing. In particular, they might have sent us like a list of, because a list of lists is obviously in the workings here. So, so I might also do something like Latin, but there's an even better trick because it checks more, and that's to do map list of number. What a codes list is. Maps list number. In fact, there's an integer, which is really what I want to say, over plane. Now, by the way, I don't have that. Notice this is subsumption. Anything that passes map list must have been a list. If you pass me something that isn't a list, what does map list do if you don't pass it a list? Map list. Let's find out if everything in this is an integer, and of course it's not. It just says false. Okay, but now what if this thing's not even a list? It says nope, can't map list over that. So that's what the behavior we want. Don't ask questions. We do these because they're interactive. Okay, and now, and yeah, if anybody's got other things they'd like me to cover, this is kind of your time to see me working stuff that is you find confusing. So let's see. Okay, a list, and we actually need more information, don't we? I'm realizing I'm going to have to know what the dimensions of the grid are. So I guess I could take, I'm going to need the length, and I can just always make one of the rules of my cipher, and this again is part of the definition that's unclear, is whether you have to send in the dimensions. That might be actually a good thing. This is a cipher after all. So let's assume we pass in the width, okay? So now we'll probably need the height. The height is then going to be it is the ceiling of the length divided the width. And that's going to be real division, but this is an integer. Kind of crazy to think that Prolog will promote, but of course it's not Prolog doing it, it is. And I think that'll do us fine. And then there's probably some Prologger out there screaming that I should have used integer division and check to see if the remainder was greater than 0, and if so, add 1. But one way or the other, we got the height. So we're now going, and I think what I'm thinking is my plan here is to make height lists of width. So I'll make the overall structure of the cipher right now. And then I will make my life simple, and then I will fill those variables in as I go. So, okay, Daniel is typing. So here we go. I will say cipher is going to be a list of the height. Okay, I am going. Excuse me. I want it to be width rows of height because I have to do this transpose thing. And then right at the end, I will just flatten it. Ceil is a function. Ceil is a function. Prolog has no functions. The is-to predicate has functions. This is the way I always assign some kind of a make an arithmetic. I'm blanking out. What was the arithmetic I asked you to make this time? I know I did it. Well, everything is a relation in Prolog, but the relationship, in this case, the relationship that is to defines is x is ceil 5/3. Okay. I guess I don't need this. Forgive me for stopping and fixing that. But, oh, sure, because the division, and we'll be fine there. But, okay, so x is ceil of 5/3. What's going on here is that we are calling is with x and with the compound term ceil itself contains a compound term called slash with two arguments 5 and 3. Okay? Yeah, this is the same thing as doing the plus 3 and 2. Obviously, you want to be able to write division infix. So division is defined as an infix operator, and this actually works. So is not actually all that special, although it obviously is going to call underneath some kind of simple arithmetic library. And in fact, somebody asked me this earlier in the course, and I looked at it, I checked it, and it's actually implemented in C. If you didn't get that earlier in the course, this is a great trick. You can actually see listing is like that, but it just says it's a C function. But, and I think append is, yep, append's defined in Prolog, and there it is, that's the code. Yes, thank you. Yes, the color mixing project. You know, I don't think anybody has shown me a color is yet. Um, Maybe one person did. But, okay. Um, so, here is, uh, so, what's going on here is that it's its second argument, expects its first argument basically to be a variable. Uh, uh, that's basically out mode. And then it expects its second argument to be a ground, that is containing ungrounded variables, a ground term, all of whose compounds are things that it knows how to break down. So if I use X is taco of 3, it throws some horrid exception, because it doesn't know how to do a taco on a number. However, if I call X is sine of 3, it'll tell me the sine of 3. That's because somewhere in the innards of is, what it's doing is it's going, oh, the entire outside thing that I'm seeing is a sine, and it has one argument. Okay, I know what to do with that. So it passes the argument to is, gets a number, and then it just computes the sine function on it with the number. And then that is and then it binds its first argument to that. So so that can get arbitrarily complicated. Daniel, does that clarify? It's definitely not a relation. Seal is a compound term, not a predicate, but it's a term that is being used as a function call in a different language. Is defines a new language within Prolog. And that language takes Prolog terms as its argument. Hey, I have a pop quiz. Everybody give their opinion. Is to is going to define a language, right? It knows. We've been talking about that. Is that language homoiconic? It's defined in Prolog data structures. Okay, I'm back to working away while the lag catches up. So the height's going to be the ceiling. We got one vote for yes, it's homoiconic, I think. And we'll let a few more dribble in before we start talking about it. So, okay, I'm going to keep coding. The height is, so let's think now. The width is going to be the width of the the graph. So do I want it represented as the input or the output? I want it represented as the output because I'm going to bind this thing to cipher, right? So the width of the output is height. So I am going to make length cipher height. I'm now going to get a list, the length of the height. I can now fill it in and we didn't cover a library, y'all, so I'm not going to use it. Those of you who are painting for lambdas, look up library YALL, Y-A-L-L, and I am going to map list well, I tell you what, I'm going to do this deliberately kind of wrong at first. I am going to get a single row, which will be of width, will be of size width. And then I could just map okay, Norbert said, but Daniel, and Daniel says, it worries me that it's you two guys who always answer, but I love that he asked it and really engaged. So other folks, I mean, we've got 9 people in the chat. Come on, the other 7 of you. Let's see your answers. Ha! I'm very tempted to not talk about it until I see the other 7 answers. Okay, I'm just going to keep cranking until I get some more answers. So there. Okay, so I could actually, I just want a row of unbound variables, right? Which would have been a column in the input. We got another vote for yes. So, map list. So I'm just doing unification. So I'm just going to map. I'm just going to set all the elements in cipher to row. After all, we just want a list of unbound variables, right? We have length. We never define length. I'm going to go back and do that. Plain. Okay. Now, at this point, the DSL wrapped around it. Well, okay, Steven, let's find the academic here. I'm teasing you a bit. Obviously, is as part of Prolog is itself homoiconic, but is defines a language. You can't manipulate the values. I have fed all kinds of weird generated things to is. I have fed. Hey, tell me if my sound goes to crap. I'm realizing my head to look at my monitor, and I have my mic on the wrong side. Okay, is so can you manipulate the values? I mean, sure, I've done crazy things. I just finished like manually typing them in as term 2 and so on. But and I'm hearing most of Stefan, those are the same. Okay. So, well, it ends the Y be grounded. That's its basic rule. And then is only knows what to do with certain things. If you pass is addict, it'll just throw up. If you pass a taco 3, as we saw, it'll just blow up. So, okay. Everybody who's saying yes. Somebody give me okay. Before I start into that, I'm going to answer Stefan's question. For length L sub n, can you do L length n? No, you can't. That's because length isn't an operator. And you could do something like this. Op. I'm gapping the order of the operands, but I think it's this. And I'm giving it an arbitrary association value because I don't have the chart in front of me and don't want to stop to look at it. If you do that, you're going to have be able to actually do that. If not, then no, you can't. Okay. So, back to what's... Focusers. If this is befuddling you, if this whole business of operators and what operators do is befuddling you, go work the color is assignment. If you've already worked it and you're still befuddled, another arithmetic, like complex numbers, 4 plus 3i. Matrix math will probably get you into a bunch of, like, writing down complex evaluation, but you could do that. I've used emoticons to demonstrate this, you could make an emoticon grammar so that the smile icon plus the pepper icon makes the red angry guy icon, but the smiling multiplied by an integer, and then you get a string of them, or perhaps you get smile. Oh. Okay. I'm waiting for people to type, so I'm going to keep talking about. I'm going to go back to working on my program. There's a problem here. We're expecting to get this square of elements. And that's indeed what we'll get. You print this out. In fact, if I try and run this now, I should get just a square that's not assigned anything, right? So I call this thing plain square cipher. Hang on, I'm going to narrow this a little so you can see my code while I work at the terminal. And I don't know. Okay, plain square cipher, and then it takes a code using a backtick. And then cipher, and let's give it 8 to make certain that we're going to get what we want. And sure as the world, we get a nested list of lists of variables, which seems to be what we're expecting to get here. But if you closely examine it, there's wrong, and that is row, although it's just a list of length width of unbound variables, we've used the same set of unbound variables every time. See, the first one in this list is 5060. First one in this list is 5060. First one in this list is 5060. We don't actually... Stefan, okay, so we're back on what is homoiconicity. All right, so operators in the function in Lisp, yes they are, but operators are a syntactic sugar that is removed at read time on Prolog. That is simply another way of writing a compound term. Prolog could be designed so that, I don't know, we're running out of paired operators, or paired terms, but we could have allowed Prolog to be written this way. That's not very useful, so that wouldn't have been a good language design. But we could have done that. It was just another way. And you could make up your own language that kind of has its own syntax, but underlying has the same semantics as Prolog. These things go away at read time, which is really the heart of homoiconicity. Homoiconicity, so def macro breaks homoiconicity. No, because let's see here, def macro executes. Sorry, you're finding my somewhat spotty memory of Lisp. It's because of that def macro works. I believe that def macro actually works because of homoiconicity. Okay, homoiconicity is defined not in the syntax of the input source file, but in the data structures that define the language. That's homoiconicity. So the question is the language defined by is homoiconic? And the answer is not. Although it's actually defined by some data structures, right? Is doesn't really have its own syntax. It has a bunch of structures. So you pass it this Prolog data structure that is what you want. Is then interprets Prolog data structures, not is data structures. Perhaps if you say, well, the data structures of is are the data structures of Prolog, then I'll buy that it's homoiconic. Okay? So the fact is that you can actually kind of answer that either way, depending on what you sort of think of as the data structures. If they're just the same set as Prolog, then fine. Erlang would have been an example of that kind of early on. Early on, it basically was a Prolog variant. Okay. All right. So, somebody tell me, does def macro is going to expand at load time or at the call? It expands at the load time. So yes, it requires homoiconicity, and it doesn't break homoiconicity. And I'm actually going to defer to Stefan here. Okay, so we get a problem here. This line. Oops. So what are we going to do? Well, what we're going to need is just a little more complicated. So I'm going to actually make myself a little predicate. I'm going to quit making one row because one row is not going to do me any good. So I'm going to make how about blank row to, I better make it width to blank row. Okay? Because it's actually just length. I just want a thing that makes a new blank row of length. In this case, it was width. Okay. Let's write that. length blank row. Is this thing just length? No, it isn't, because it's got the arguments in the other order. So, hey, okay, let's just fix that. So here's n and length. And by the way, I think everybody on Earth agrees that if we were doing length again today, we would flop the arguments. And because we've all written this 100 times or used library y'all. Okay? All right. Now let's try my test case again. And now, okay, this one starts 3616. You can't see my fingers. 3616. So let's find one of these later ones. 3856. So these are all different variables. That's exactly what we wanted. Okay. And now, we are going to finish filling that in. Okay. And then we will fill this in. And this, but don't get too excessive about it, is probably an okay practice. I'm certain there's some Prolog programmers screaming in them right now, but I'm going to take plain, and now that I have this thing, I'm going to flatten it. Do what? Because ultimately, I want something where I can map various arguments of one into the other. And that's easier to do on the square version. But it's going to make me a whole new list whose elements share with the elements in Cipher. So this is going to be sneaky. I will do Cipher. And I shouldn't have called this, I shouldn't have used Cipher because it's the flattened version. Let's call it Square. And this is Square. This is Square. Okay. Well, if I call this now, I'm just going to end up, again, equal length thing that is just a list. So let's see what we get now. And sure as the world. And notice one thing. We aren't getting these in order. We're getting 16, and then 22, and then 28. It's not of equal length. Tell me what, I don't know what the arguments to, I don't know what it refers to. You've used a pronoun and left me puzzled what the pronoun means. Oh, it's not equal length. Yeah, right. It's not equal length. I get it. Now I get it. Yeah, the point is that if you try and do this with a length of a plane being a length of 23, of course, 23 isn't the product of two numbers and the product of two integers, so we're not going to end up with a square. We end up However, the way I've done this, I used seal, so it's always going to be bigger. So what we're actually going to get at the end, and again, as a design decision, I love the way Prolog ultimately ends up kind of like things out to you instead of like hiding them from you. I know it's much like a. That's why I'm not so yorked about it being typeless. Yes, it's going to have some at the end, but it's like, okay, well, you got these at the end. What do they mean? And then we will have to cope with them. All right, so at this point, I've got the thing, but I still haven't assigned them, right? So, so I made one of these. And I now need this thing. Okay, I'm going to write. It's left to right. And this says bottom to top, but let me point out that the top and the bottom is just kind of a matter of opinion here, right? So I'm going to make my cipher top to bottom just because it makes my life a little easier. And I'm running out of time. Okay. So I can do so now I'm going to take the input and I'm going to chop it into chunks of length, width, or less. Yeah. As David's. Okay, I am going to let's see here. As chunks, right? Because this way, when I have two things, I have plane and chunks, and then I need to put the width. And let me tell you, when you know, if you're going to have lists and you suspect, put them kind of to the end, or if you have a choice. The rule is put the things that are in first, the things that are out on the end. Oftentimes, the first arguments are going to be some kind of parameter setting. Like in our case, we want to cut it into chunks of length width. All right? And then as length, as chunks, and then we are going to does this look right? Did I flip it? Length of the blank row, width, and I get height of them. Except, do I want to flatten them? I may be getting myself into transpose trouble here. Okay. If I'm going to flatten the square, then fine. Each I have these backwards, don't I? Yes. Because when I flatten them, I want them to look like that. I want them to look like the output. Okay. All right. So I want as chunks of oh, you know, I actually have to stripe this thing off. Because I'm not depending on it being square. Okay, I'm going to have, I want cipher. I'm going to do it for 3 by 4 for an input of 12. So the input will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The output will then look like 1, 7, 10. Yes, so I can't simply do some cool trick with setting up two structures and mapping one. That ain't going to work. I could use the transpose function. I'm kind of avoiding it because it wouldn't have been interesting. Flattening the square. Would you first want to maintain the structure before flattening? I am maintaining the structure before flattening. The structure, Prolog structures are immutable. I couldn't change it if I. The structure before flattening is called square. Probably a bad choice, as we've just seen. Or 710. Just because it's not in. Not necessarily doing things in your imperative order. Okay, that's what I want. So now, I guess what I'll do is search through the input and bind the output. All right, so far I haven't done anything I can't order I want, pretty much, except for compute some lengths. Okay. Yeah, you notice when I do flatten, I still haven't filled in any of the values. They're all unbound. They're now sharing down. Okay, so now I'm going to map values much better. I might make that map values transposed if this was more serious code. Okay, I got started a few minutes late, a little over, and this week is kind of just to help folks. Anyway, so I will just keep going and probably try and finish this. I think we're close. I will do map values, and the values in plain, and then cipher. This is the enciphered values. So I'm going to take the values in cipher and map over them. Okay. Yes, if I map list would pass in the extra, but what I'm doing here is I want to make certain that I go through the list that I want, and I'm thinking, well, okay, what I want to do is I'm going to grab a chunk I'm going to grab an inner list out of cipher, and then I'm going to just find 4, 7, and 10. I'll then go back. Okay, map list, plain, and cipher, and so I'm going to map over cipher so that it makes sense to make cipher the first one. Just Prolog. Plain is actually now an argument. Extra argument appended or prepended. It goes on the end. Yeah. For example, plus is, I think there's an add. Nope. It's called plus, I think. Plus? Yeah. Yeah, there's this thing because adding is so common. So suppose I want to add 2 to a bunch of things in a list. With map list, I could do plus and then 2, and then the list 10, 20, and this will be the list I want out, and it adds it to all of them. Okay, so map list will add as many arguments as there are. So in this case, it's adding 2 of them, and I have a plus of arity 3. Okay, back to map values. I need plain, and then I need the width with which to the cipher. Okay. And that's the width in the cipher, which is down here. So that's going to be 4. So that's actually going to be height. Here, this is part of our transpose issues. And now I no longer need as chunks. Okay. So now I'm going to have to write map values. Okay. Yeah, I could do a map list on the chunks. The problem is I need a count of how far I am into plain. And I'm not picking the values out of plain. I'm about 0 to get the values out of plain. So, this is actually map values into, yes, cipher. Well, first of all, I need a base case. If I have nothing more to do, I don't care what's in plain, and I don't care what the height was. I'm just done. It looks a little funny. I don't seem to have any output, but remember, all I'm trying to do is ground a bunch of variables because they're shared to something. So, a row of cipher, and the rest of the cipher. Plain, which I always need the whole thing, because I don't really know when I'm going to need number 1. And I need, I'm going to make it the width, because I'm kind of referring to things in the I'm going to call this the cipher width. By the way, here's a case where better variable naming would have saved my patootie. If I had gone back and calling this width, I had called that plain width. Then I could have called this plain height, and we would have had a lot less confusion. So, okay. You see why I'm going to always need, okay. And now I need one more thing, and I need to know what number of row I'm on. So, map values, and this is the row I'm on, and I don't care what row I'm on either. So here I have the plain cipher width. And yeah, we should refactor this. Okay, plain and cipher are pretty good, but this is, even the caller needs to know this. Like, do you mean the width of the plain text or the width of the cipher? And I think we mean the width of the plain text. By the way, we got a mistake here. Let me think. I have a... Why am I making a thing? Oh, okay. Width is actually the... we have the other major order. So, width is going to be height in this case. Yeah, I suspect we're not making the right number, caught by having better variable names. Yeah, why don't I make clear? I'm renaming manually because I'm in a minority. But you guys will notice I don't use lots of editor complex regexes. I don't try it as fast as possible. Honestly, this is just, I've been a programmer a long bloody time. Long enough that it's before the days of good editors, when, you know, we were on 40-column screens and so on, and just having to interact slower with it caught a heck of a lot of bugs. So I deliberately use somewhat pessimal editors. I use this thing, and unless I've got 400 things to change, I'll do them manually. I don't use very fancy tools. I know Emacs. At one point I was a QED hacker, which is QED is the Multics version of Vim. Maintain like stuff like basically business applications that were written as Vim macros. But nah, I do a surprisingly large amount of my work in gedit. I question this decision. So, does anybody know whether the plane width or the plane height? All right, I'm just going to pick one, and I may actually have to change the code. So that's got to be the plane height. And now, square, it turns out, is not. Square is the encipher. Okay, square's not so great either. Nested cipher. Call it that. And that was a mistake. Was that square? It was. Okay. Okay, see us, Norbert. This then is going to be okay. This is all beginning to be happier. I think we chose the right one. And map length blank row, and we're going to get a height. Use where the heck's length blank row? Okay. Length blank row. We're going to ask for heights in plain heights, which is cipher widths. And okay, all right. So, woohoo! Yay! Am I losing my audience? Nope. There's 11 of you out there. I'm glad you're here. Let's hear from some of the folks that we haven't heard from. Are you guys out there, or how are you doing? I do try and check in with people, as some of you know. But I've kind of lost that because we're not filling in, like, you're not so much driven by assignments, and you're just at the moment. So, although quite a few of you, I do at least I don't look through the class manually every day. I look through the class, but I at least have a graph of how many assignments, how many people have done each assignment, and I at least watch that, and so I know when you're coming up. Do keep up with, like, pressing the buttons as you finish things. That's helpful to me. Okay, cipher row, and then cipher rest, and then cipher width. That's believable. Okay. So, all right, we're going to map values. CPH, and then I get to talking, basically, and map values. My intent, was to, and yeah, I'm kind of reconsidering. I just had an experience of working with some guys who definitely were the last time I learned to fly in Emacs, and yeah, maybe I took the wrong path there. But okay. So here we go. Cipher row and cipher rest. Fine. So I'm going to take cipher row. I could get its width. Are we calling it weird or width? So W would be better? No, that would not be finished refactoring from height and width because, oh, maybe you're suggesting two. Nah, I'm currently in a long variable names phase, and we've had confused these mean. Let's leave long variable names for a moment because we've just demonstrated that we had problems with that. Okay, going to need the index we're at. Now this could either be what row we're on or our index into the plane, into the cipher row. So, okay. And now we're going to need a helper that does one row. And I got an offset. With, by the way, I'm only passing this because I don't want to recompute the bloody thing. I do have cipher row. I could call length on one of its rows. But that's kind of being unrealistic. So is defined as, let's fill in all the rows, all of that for one row, and then I need index to do that. And I need the width. Do I need the width? Yes, I need the width because I need to compute it. I need it to compute. We need to grab my value. And then yeah. A cipher row is not an input or an output strictly. It is partially bound on input and hopefully fully bound on output, unless it's one of those few right at the end. And by the way, we're about to run into that of the not a perfect square, or not a product of two numbers. So, okay, map, and I may have to call a halt to this at some point because it's unfair to people that have to hang out watching this much longer than they expected. Okay, map, and then map values. Cipher rest, plane, cipher width, just sort of constants, and then the index, I need to compute the new index. Okay. And then, if this is done, we don't care what the other stuff was. If it is done, we need plain, we need the cipher width. Oops, we got a problem. We don't need the cipher width. We need both the cipher width and the cipher height, because the cipher height is the width of the plane. I got plain. Let's see here. Oh, I got cipher width. I need plane width. All right? So, hey, and I'll warn you, there's an anti-pattern that would seem obvious, and that's to, like, shove two variables into one with a minus sign. So have, like, plane width, cipher width. But you don't really want to do that. Okay, that is, we said that was plane height. I need the plane width. So, and again, bad variable names are being bad on me. And now I want the plane width. Okay. And I need to add, which is the plane height is the cipher width, so life is good, and plane width. Boom. All right. Let's cruise down. I am going 1, 2, 3. My arity is 5. There's one more thing I don't care about, right? And otherwise, I have the cipher width and the plane width and the index. So yeah, folks, feel free to drop off. I'm gonna keep doing this. I think I will, for those who are interested, I will finish working the problem. That is cipher width, and then thanks, Arjun. See ya. I probably should stop waving at my screen. Okay. And then map 4. Plane width. Okay. This needs one more. And yeah, sorry folks, this has been a bit more of a slog than I thought, but yeah. Demo of a something that's a slog's not all that bad. Okay. And now we're going to take H, and we know what index H is. And then, and once again, bad naming has hung us. And this is the index into the cipher. By the way, a thing I've done before to deal with like repeated long variable names like this is comment and say W means width, H means height, C means cipher, P means, and then use CW and PW. But it's definitely a choice to type faster, expensive than always having to kind of expand those. So, all right. So I'm going to get, I have nth 0. My brain is going bad. It's terrible. I can never remember whether the n comes first. Index list element. Okay. So then I need the plain index. I need slack back. Index list element. Okay, that's the order. I need the plain index. The list I want it out of is plain. And there's the plain element. Now we got one problem here. While indexes actually would work in this this mode, it'd be really inefficient because you'd have to keep it'd have to dig through all the values of plain and keep offering them to me until I got the right one. So I really need to, and I'm going to have to at some point make certain the plain index is the one I want. So we better compute it now. Does sense to people why I'm doing this in this order? Plain index is so plain index is the cipher in 0, 1, 2, 3, 4, 5. The cipher index, okay, I'll pick that one. 6. All right. 6 is 4, which is going to be, well, I'm going to compute. I'll tell you what, let's do this in the sane way. Well, cipher index is how many into the cipher I've got. But plain index is how many 1, 2, 3, 4, 5, 6 plain X index is going to be the, so I'm going to get cipher index. I'm going to row in a value. Cipher row is div row and column are the width, and then And then plain is the cipher row plus plain width call. And that's where our scrambling occurs. Okay. Plain element. The plain element, however, is just H. Because the plain element is the element I want to stick in H. So I just want those two to be the same. So I'm going to unify them. And now I will say map values row T stuff remains the same. This, by the way, is how you make it. You would make a bug using your editor. This is not right because, of course, I have to increment cipher index. So I could say suck cipher index and NCI. Okay. And guys, I'm running so that at this point I've kind of worked the problem. If I have debugging, it's going to take a little while, and I don't want to do that, right? I think I better call a halt, or I'm being abusive of the time you've given me. So, thank you. I am going to sign off at this point, and I'll see you back on Slack. And in a couple of days, we'll see. We'll be ready for advanced class. Yay! And we'll start on planners. I'll see ya. I'm seeing a few people typing. Oh, we'll wait for them to respond. Yay, thanks. I'll see ya, guys.